Today, we're going to do something a little different. We're going to crack the code on the language of chemistry.
Okay, let's be honest. Have you ever looked at a bunch of chemical symbols and just your eyes glaze over? It feels totally like trying to read a foreign language, right? I mean, it's got its own alphabet, its own grammar. It's no wonder it can feel so intimidating.
But here's the thing, it is a language, and today we're essentially handing you the dictionary and the grammar book. We're going to break it all down, piece by piece, so that you can start to see what's really going on, to understand the amazing stories chemistry tells us about, well, everything. So, you ready? Let's get into it.
All right, so first things first. Every single language starts with its alphabet, right? Well, in chemistry, the letters, they're the atoms, and we write them down using what we call chemical symbols. It's super straightforward. A symbol is just a 1 or 2-letter abbreviation for an element. Think of it like this. O is our letter for oxygen, H for hydrogen, C for carbon. These are the absolute most basic building blocks, our ABCs. You know, it wasn't always this neat and tidy. Way back in the day, around 1807, a guy named John Dalton used these really complex drawings, like little circles and shapes. It was kind of messy. Then, a few years later, another chemist, Berzelius, had a brilliant idea. Hey, why don't we just use letters? And boom, that simple upgrade changed everything and gave us the system we still use today. Okay, so you might be looking at the periodic table and thinking, wait a minute, why is gold AU, or why is iron Fe? It seems random, but there's a good reason. A lot of these symbols actually come from their much older Latin names. So Fe for iron comes from ferrum, and Au for gold comes from aurum. It's a really cool little history lesson hidden right there in the symbols. Okay, so we've got our letters, our chemical symbols, but you can't just mash letters together and expect them to make sense, right? You need rules. You need grammar. And in the language of chemistry, our grammar is something called valency. So what is valency? In a nutshell, it's an atom's combining power. It's a number that tells you how friendly an atom is, how many hands it has to hold hands with other atoms. It's the set of rules that tells us which letters can connect and how.
And this combining power really comes in two main flavors. You've got your positive valency atoms. These are the givers. They're happy to lose an electron or two. Then you've got your negative valency atoms. They're the takers. They want to gain electrons. And it's this whole dance of giving and taking that actually forms the bonds that hold everything together. All right, this is where it gets really cool. We have our letters, the symbols. We have our grammar, valency. Now, we can actually start writing our first chemical words. And these words are what we call formulas. So a chemical formula is basically the written word for a molecule. I mean, think about the most famous one in the world, H2O. It's so simple, but it tells you everything you need to know. One molecule of water has 2 hydrogen atoms and 1 oxygen atom. It's perfect shorthand. So how do we build these words from scratch? There's actually a super simple, almost like a recipe that you can follow. It's just 4 steps. You write down your symbols, put their valency numbers up top, and then you do a little swap. Let's actually see how it works. This is the famous crisscross method. It's a fantastic trick. Okay, look here. We take sodium, Na, which has a positive 1 charge, and chlorine, Cl, with a negative 1 charge. You literally just take those numbers from the top and crisscross them down to the bottom of the other atom. Since they're both just 1, we don't even need to write them. And voila, you get NaCl. You just wrote the formula for table salt. How easy is that? Okay, so we've gone from letters to words. The next logical step, sentences. And in chemistry, our sentences are chemical equations. And these aren't just any sentences. They tell the story of a chemical reaction. Think of a chemical equation as the plot summary of a story. It's an incredibly powerful shorthand that tells you what happens during a chemical change. It shows you the characters at the beginning of the story, the reactants, and what they become at the end, the products. It's the whole story of transformation, right there in one line. And just like a sentence, it has parts you can recognize. Over on the left, you've got your reactants. That's your starting point. On the right, your products. That's what you end up with. And that arrow in the middle, that's the action. It's the becomes or yields part of the story. It shows the change happening. But hang on, there's one more really important rule to this whole sentence writing thing. You always hear chemists talking about balancing an equation. So what's that all about? Why is that so non-negotiable? Well, it all boils down to one of the most fundamental rules of the entire universe, and that is the law of conservation of matter. It's a big name for a simple idea. You can't just create matter out of nowhere, and you can't make it disappear. In a chemical reaction, all the atoms are just rearranged, like Lego bricks. Every single piece you start with has to be there at the end.
So if your equation is unbalanced, it's not just bad grammar. It's like you're writing science fiction. You're saying that an atom just popped into existence or vanished into thin air, which can't happen. And this is so important. Getting this balance right is absolutely critical for, well, everything. From making the chips in your phone to creating medicines that save lives, the recipe has to be perfect.
So how do they solve this puzzle? One common way is the hit and trial method. It's kind of like a logic puzzle. You start by just counting up all the atoms on both sides of the arrow. And as you can see at first, they don't match up at all. But then, by tweaking the numbers in front of the molecules, you adjust and recount until, bam, the final count is perfectly equal on both sides. Now the equation tells a true story. Okay, let's take a breath and put all these pieces together. We've actually just learned the fundamentals of a whole new language. Let's do a quick recap. It's simple, really. The symbols, those are your letters. The valency, that's your grammar, the rules of the game. The formulas, those are your words. And the equations, well, those are the full sentences that tell amazing stories. Which means you can now read this. Seriously, look at it. This isn't just a random jumble of characters anymore. This tells a story. It says if you take 2 molecules of hydrogen gas and react them with 1 molecule of oxygen gas, you get 2 molecules of water. You're literally reading chemistry right now. So, next time you come across a chemical equation, don't let it scare you. You have the key. You know the basics of the language. Which leaves us with a pretty big question, doesn't it? If this is the language that all matter speaks, what other amazing stories is the universe trying to tell us?